start, and I will let other people come in when they are ready. Okay. So thank you for coming. So today, or this session, we are delighted to have Mark Sargent, all right, to give us a tutorial or talks on wireless evolution, basically focusing on the 5G. Okay. So let me just introduce Mark. Mark is a vice president of the certification program at CTIA, where he oversees the US wireless industry certification program for consumer wireless device. So obviously it's very related to IoT nowadays. So in this position, he is also chairman of CTIA industry-wide certification program working groups. Mark has 30 years of experience in the telecommunications industry, having held various engineering, sales, marketing, product developments, and operation position. He received his BSEE from Pennsylvania State University and an MBA from Duke University. Okay, thank you very much.
All right, thank you, Nicholas. Good afternoon, everybody, and I appreciate the opportunity to speak to you all about 5G. It's a very interesting technology that is currently in development right now. So I'll give you an overview of what you can expect with the upcoming 5G wireless technology. So what I'd like to talk about today is I'll give you a very brief introduction of my organization, CTIA. We'll talk about the wireless G evolution throughout the years. We'll then talk about the present status of the technology, where we are today, and then where we're going in the future. What are going to be the requirements for 5G? What is needed to actually implement 5G? And the timeline. How is this going to play out? When can you expect to see the 5G? And then we'll wrap up with a brief summary. So I first have a very brief video. Oops. I'm sorry, I'm hitting the wrong buttons here. Here we go. So about CTIA, we are a nonprofit membership organization. So we represent the wireless industry in the United States. We've been in existence since 1984. One of the things we do is we advocate at all levels of the government in the United States. We advocate at the federal level and also the individual state level in the US. The states have individual requirements, so we work with state legislative bodies. We also coordinate various industry initiatives among our member companies. Some examples are recycling and sustainability. We have a website, Go Wireless, Go Green, that talks about this topic. We also coordinate campaigns on safe driving. We've done that for over a decade to educate users of technology about distracted driving, both speaking on the telephone and texting while driving. And we also have another example is we have another website called growingwireless.com, which educates parents about how to speak to their children about using wireless technology sensibly. We also provide an industry certification program, as Nicholas mentioned. That's what I'm in charge of. So we do testing and certification of consumer wireless devices. We have authorized test labs throughout the world that test these devices and ensure that they're going to perform correctly before they reach the market. And finally, we also operate a trade show that we call CTIA Super Mobility. So if you love Las Vegas and want to learn more about the future of mobile technology, we're going to be back here in September of this year at the Sands Expo Convention Center. Okay, and now I have a very brief video. This is a compilation of commercials from some of our member companies, so it'll give you a little flavor of our member companies and what they do.
2015 was a great year for America's mobile consumers. Here are some of the reasons all segments of the wireless ecosystem helped America's wireless consumers benefit in 2015. Licensed spectrum for wireless carriers generated more than $400 billion annually in economic activity. For every one job in wireless, another 6.5 are created, and those jobs pay 45% more than average. More than 93% of Americans are able to choose from at least 3 different 4G LTE network providers, and that's thanks to more spectrum, as well as more towers and antennas to expand coverage and capacity. To new plans.
Add up to 10 lines and share your data with family or friends.
From cool new apps and services to new devices. It's clear who benefited the most from 2015, America's wireless consumers. And as Americans enjoy even more mobile-first lifestyles, CTIA and America's wireless companies will continue to innovate and compete to provide you with the best. We look forward to serving you in 2016.
Okay, so again, these are some of our member companies, wireless carriers here in the U.S. like AT&T, Sprint, T-Mobile, Verizon, manufacturers of the devices like Samsung and Microsoft and Apple. The whole network infrastructure the wireless runs on, companies like Ericsson and Alcatel-Lucent and the companies that make equipment to test all these things we actually use within our certification program. So really, companies that provide both products and services for the industry. So let's talk about the wireless G evolution. So G stands for generation. The tutorial is on 5G, so that is the 5th generation of mobile technology. So what were these generations? So just to put some context in place here before we jump right into 5G. Let's roll back to 1946. We'll call this pre-G, the very first mobile telephone call. So there was a team of engineers at Bell Labs. They worked for about a decade to actually accomplish this feat. And by 1948, there was AT&T mobile phone service in the US, believe it or not. It was a single tower that would provide service for an entire city. Just a few channels were on there. There really wasn't a big demand for this, obviously, back then. It was used by truckers, reporters, utility workers. I believe eventually there was coverage in maybe 100 cities in the US and highway corridors. So now let's fast forward to 1983. So this is really the first generation of cellular technology. Here in the US, we had AMPS, Advanced Mobile Phone Service. Europe had a couple systems, TAX and NMT, I believe operating at 450 megahertz. In the US, the frequency band was 800 megahertz. And all you could do was make a phone call, analog voice call. As an example of the device, manufactured by Motorola, affectionately known as a brick. It weighed about 2 pounds, sold for $4,000. So not very many people had these devices. But obviously it took off. So 1991 is when we had 2G. And this is where things really began to take off, because now your handset has shrunk. So, and the technology then became digital. So now your calls were over a digital network. GSM was created. This was widespread throughout Europe is where it got started. It's still very widespread. We also had TDMA and CDMA networks that were introduced as well. You also had, in addition to the digital voice call, text messaging. This was introduced over on 2G, SMS, short messaging service. So now that wireless began to take off, people began to think about, what else could I do with wireless? What else can we do in addition to making voice calls? So now people started thinking about data. So what we'll say is 2.5G came into existence around 1997. And you had a couple technologies that were basically, I would call them extensions to the network, extensions to the GSM network. General Packet Radio Service, GPRS, and EDGE, Enhanced Data Rate for GSM Evolution. So here you've got a packetized network, packet switch data, running on the GSM network. And now you could do some real true data service. Not very high speed, but it was really the beginning of data on mobile. So that evolved into what was the true 3G, approximately 2001. And here's where your data rates really started to take off. Because again, as people started using more and more of this, there was more and more of a business need for data. So you had technologies introduced like UMTS and CDMA 2000. And this is when you could access the internet over a mobile device for the first time. So you could do some web browsing on your phones. And you had specialized devices specifically for accessing the mobile internet, like USB dongles that you would connect to your notebook computers. So you could access the internet through your notebook. You could browse the internet on your phone. It worked pretty well. You weren't doing any real, anything very, very high speed, but you could do some pretty good web browsing. So that takes us to 4G in 2009. Now you had another big incremental boost in data speeds. So now you're going to do some video streaming with these data speeds. You really couldn't do that before. The technology that was introduced to allow you to do this was LTE, long-term evolution. And this is what we have in place today, and it works very well. So again, it's the 4th generation because you've got a whole new application here with video. You got very high data rates. So now we've got 4.5G. We're now starting to transition to the next generation, 5G. So this year is when we're starting to see LTE advanced technology. So what is happening now is you have a technology called carrier aggregation, where network operators are concatenating multiple carriers to provide even higher data rates to the user. So you can do even more bandwidth intensive applications. So much higher speeds. So again, the data rate is really what's driving the technology up until now. The second thing that we're starting to see is enhancements specifically for the Internet of Things. So this is just the other thing that's driving the future technology. So the networks up until today really have been designed for speed. All about providing higher and higher bit rates so you can do more and more things. But there's also a big application for IoT, which in a lot of cases doesn't need speed. Internet of Things needs typically low data rates because you're communicating very small bits of information. But what you also need is lower cost too, because a lot of these components that are being incorporated into devices using the internet need to be very low cost. And the network really, up until now, has not been designed specifically to support that. So there's some extensions that have been introduced by standards bodies called LTE Category 0 and LTE Category M that provide some technology to allow lower data rates for the modules that will support M2M, and then also a lower bill of materials cost. You take a lot of the functions out that you don't need for things like smartphones, and you can provide a different level of service for IoT users. So now we're looking at 5G. We're going to start seeing commercial deployments about 2020. So in about 4 years is when you can expect to see 5G. The ultimate goal is an end-to-end ecosystem to support a fully connected and mobile society. So you can start to see that happening already. Almost everything we do is incorporating mobile technology. So what we need is a new generation of network to support that in all aspects, to support both the high-speed video streaming and also to support this very low bandwidth which is needed for IoT. So the network really needs to be designed specifically for these things. So let's take a look at what's driving the data traffic. So the part that's driving the very high bandwidth needs. What's causing this? So there's some very interesting statistics here. You can see the source at the bottom. There was a report by Cisco that looked at the data traffic forecast from 2014 through 2019. This is where these numbers come from. So first you've got more mobile users. So 2014, a little over 4 billion mobile users throughout the world, forecasted to grow to over 5 billion by 2019. You've got more mobile connections. 7 billion in 2014, forecasted to go to 11 billion in 2019. And if I have my figures correct, I believe the 7 billion exceeded the world's population in 2014. So now you've got more mobile connections than people. Faster speeds. Again, we keep coming back to this. About 1.7 megabits per second in 2014, forecasted to be on average 4 megabit per second in 2019. And you'll see later in my presentation, you're going to get much higher speeds than this, but this is what Cisco is forecasting as a typical speed, but the networks will support much, much higher than this. More mobile video. 55% of traffic. This is unbelievable. In 2014, over half of the traffic on the network is video. And by 2019, that's forecasted to be about 3/4 of the mobile traffic, just for video. So let's take a look at the growth of this mobile data traffic over the years. So this shows the traffic in exabytes per month, which is, I believe, is 1,000. An exabyte, I believe, is 1,000 gigabytes. So this is a lot. So about 10 times increase from 2014 to 2019. Another order of magnitude above. Oh, so you got gigabyte, terabyte, exabyte. I'm sorry. You're correct. Oh, and petabyte. Okay. So it's huge. Yeah, this is compound annual growth rate, 57% each year. And what's driving this again? It's video, because video is the most bandwidth intensive application. That's really what's driving the data here. So where are we today? At least here in the US, we have pretty extensive 4G coverage. Greater than 98% of Americans are covered by a 4G signal. There's over 200 million customers using 4G here in the United States. We have VoLTE technology in the network, that is voice over LTE, basically voice over IP, because LTE is an IP-based network. So VoLTE technology was introduced by some of the network operators in the US in 2014. Last year in 2015 is when some of the operators were introducing the LTE Advanced with carrier aggregation. So this is your 4.5G, where you're taking multiple carriers, putting them together to support these higher data rates. In terms of the economy, it obviously supports a pretty big economic contribution, $400 billion annually to the economy. There's 1.3 million jobs in the US supported by wireless technology. There was a study that showed that each wireless job creates 6.5 other jobs. We also have this growing Internet of Things market. So again, two key things. You've got the growing bandwidth applications like your video. You've got the growing IoT market. If anyone had the time to walk around the trade show floor, you saw so much of this this year, and every year it just gets more and more. I just have a listing of some of the example applications here. These are just some sample vertical markets. Utilities are using the technology for smart metering, electric meters, water meters, gas meters. Those can all be read and controlled remotely over the wireless network. And in the public sector, there's multiple applications. A couple examples, street light management. You can manage these a lot more intelligently. You can save a lot of energy by doing this over the wireless network. Traffic control can also be done a lot smarter in order to keep the traffic flowing a lot better. Trash containers. You'll see these out there if you pay attention walking around some cities. You see these solar-powered trash containers that signal when they're filled and need to be emptied, and they do this over the wireless network. Vehicles, many applications. You saw these in the automotive area here at CES. Lots of fleet management applications where the fleet owners can track their vehicles and monitor the speed of the drivers, monitor the route, monitor the fuel efficiency. There's lots of telematics applications. All the new vehicles have this technology built in there for navigation, for music, etc. Healthcare, there's a whole segment of the floor this week devoted to healthcare applications. A lot of remote patient monitoring uses, things like blood pressure readings, glucose readings. Doctors can access those remotely. So if you have very rural areas where you might have a physician supporting lots of patients in a very widespread area, he could do those things over the wireless network and take a look at all the vitals. Personal fitness, another huge area, another specific part of the show floor here. You see all the wearable technology that's out there that communicates over the network using the GPS system, for example. Agriculture, another big industry where farmers can be more productive, utilize technology to drive down their costs and improve their crop yields. And I've got another video here that actually shows an application for the agriculture industry. So let me get that going. Oops. Let's try this again.
We here in the U.S. must become more efficient.
We need every little advantage we can, and precision farming plays that role. What we have here is an auto steer, which is capable of driving the tractor automatically. The driver doesn't even put his hands on the steering wheel.
John McKee's auto steering combines GPS with a cell phone that triangulates his precise position from a known base station. This puts John's tractor on the very straight and narrow, keeping it within 1.5 inches of a perfectly straight line.
It eliminates overlap and therefore 15% in labor, fuel, machinery, everything.
From tilling to planting to harvesting, precision steering improves John's profit margins by getting his crops out of the field and to the market faster and more efficiently.
One of the interesting things I saw on the show floor as I was walking around, drones all over the place. And most of the applications you see, you know, for the drones are video applications. But I stopped at one booth where there was an application just like this. So now the next evolution of smart precision agriculture will be a drone. So there was a company showing a spectral camera attached to a drone, flying up. It can go up to, I believe, 500 feet, flying over a crop. And one example they were talking about was a vineyard. And they would do spectral photography of this vineyard and taking multiple pictures to look at the crop and the reflection of light across the different spectrum, things you can't see with the human eye, captured all these images in the camera, and then took that and did some data analysis to determine what the health of the vineyard was, what the health of the vines was. And right now, those images are captured in the camera's SD card. So as soon as the drone is done taking all these pictures, it lands. The farmer or owner of the crop takes the SD card out, pops it into the computer with the software that this company makes to do all this analysis. One thing they're looking at doing is now sending that data over wireless. So instead of you having to take the SD card out, as it takes these pictures, it can then send all this data over the wireless network to do that processing. So I thought that was really interesting. All right, so let's talk specifically about 5G now. So what are going to be the requirements for the new generation of network? It's going to be optimized for high throughput. It's got to support the growing data traffic. Again, this is the key theme. The traffic is growing faster and faster. It has to support video and virtual reality. You see a lot of virtual reality applications here on the show floor. That was another big area. Very, very high bandwidth. So in order to do virtual reality over a mobile network, you need very, very, very high speeds. The networks today really won't support this. So what are the applications for virtual reality here? Most of what you see in the show floor, at least what I saw, was gaming applications. Now, you could do some gaming over the wireless network. You know, I suppose people will want to do that, but there's also some business applications for this too. Medical training, for example, is one application that's being looked at for this. So this training can be done remotely over the wireless network and using virtual reality to look at the human body. The other thing the network is going to need to do is, again, it's going to need to not only support IoT, but it has to be optimized for IoT. So again, the 4G networks we have today and 4.5G, they're supporting IoT. We have these add-ons that are supporting IoT, but the network really wasn't specifically designed for IoT. 4G was designed for high speed. 5G is going to be designed both for high speed and for IoT. It's going to need to support devices that are going to need very long battery life. So it has to support a massive amount of sensors that are going to be out throughout the world, and some of these are going to be in remote applications where there's no electricity, and the owners are not going to want to replace the batteries very often. So we're looking at a battery life of about 10 years. So in order to do that, we need very low data rates. The devices are only going to wake up when they need to wake up and send information. There also has to be a very low latency for some applications too. So in the Internet of Things, you're going to have some mission critical applications such as vehicle to vehicle information. You're going to have vehicle to infrastructure where the cars are talking to traffic lights and communicating with each other, and this has to be very low latency. So the only way this is going to work, if you're driving down the road and your vehicle is talking to another vehicle or talking to traffic control, is the latency, the response time has to be in the order of milliseconds. So that's going to be supported on 5G in order to enable these types of applications. It's also going to support a mix of traffic. You're going to have some high mobility uses, high-speed trains, for example, where you need to support users moving at perhaps 500 kilometers per hour. And then low to no mobility. A lot of the IoT applications are going to be static applications. So the network is going to have to be aware of what the usage case is, and it's going to be optimized to support different types of users. It's going to know when I've got a high mobility user, I have to provide some mobility management applications, and I'm going to provide a certain level of service for that. It's going to know when it's communicating to a device that is a remote sensor and only needs a very, very low data rate, no mobility management, different level of service. Seamless user experience. So what do we mean by this? Regardless of where the user is, he should expect a consistent data rate and also latency. Today, this can vary depending on where you're located in relation to your cell site and what kind of signal level you have. You might have a much higher bandwidth if you're very close to the cell. As you move to the edge of the cell, you get further away from the base station, your signal goes down, and you'll notice that too. You'll notice that if you're streaming video or you're doing web surfing, your quality of service really varies, and a lot of times it varies based on your signal strength. With 5G, the idea is you're going to get the same experience regardless of where you are. If you're on the edge of the network, the edge of the cell, you should expect the same level of experience that you expect in the center of the cell. Same thing with this latency that we talked about. If you have an application that needs a very low latency because it's a critical application, you're going to get that latency whether you're in the center of the cell or the edge of the cell. We're going to move from a network KPI to services KPI. And this is something that the operators really want to be able to provide. KPI, key performance indicator. In the past, it's really been focused on speed, higher and higher speeds to support all these applications, web surfing, video. So now with all these different applications, some needing high speed, some needing low speed, the operators want to provide a service KPI. It's not so much about the network, so it's really going to be focused on the user and what that user needs. It's end-to-end performance, basically. So those are the requirements. So what is needed in order to support these requirements? One thing that's needed is additional spectrum. So in order to support these very high bandwidth applications, we need spectrum in higher bands. Today we're operating in what we call here the low band here, 450 megahertz up to about 3 gigahertz. We're going to need new spectrum in what we call the mid band, 3 gigahertz to 6 gigahertz, and the high band, 6 to 80 gigahertz. And what are you going to get with that? Your data rates. So in the low band, you're going to have data rates of up to several hundred megabits per second. Mid-band will give you up to about 1 gigabit per second, and your high band about 10 gigabits per second. And those of you who studied communications theory know that this is governed by Shannon's capacity equation. So basically the channel capacity in bits per second is a function of the bandwidth. So you got to have these higher bandwidths to support these higher data rates. But again, there's no free lunch. There's a trade-off. The higher in bandwidth you go, the greater the propagation loss. So when you're using these very, very high bands, it's only a short distance. So if you've got a cell site that's going to be operating in these higher bands, it's only going to be able to reach a very short area. So you're going to see much more density in cell sites. So in a city, for example, or maybe a soccer stadium, you're going to see lots of cell sites in order to provide high bandwidth applications. So if we have people in these sports venues who are wanting to stream things on their phones or tablets while they're in the stadium, you're going to need to provide very high bandwidth, lots of cell sites at these upper frequency ranges. We're also going to need multiple radio access technologies. LTE, that will still be in existence for 5G. There's still a lot of room left for the LTE technology. There's still a long ways to go. Wi-Fi will be an important part of 5G. And you're going to have new technologies that are being created right now that are going to take advantage, most likely will take advantage of these very high frequencies. So when these new radio access technologies get introduced, most likely they'll use the high technologies. LTE will use the existing technologies we're using today. And the networks will be smart enough to be able to select the appropriate radio technology for your application. You're also going to have new antenna technology. So you're going to move from antennas that look like this on the left to antennas that may look like this on the right. So on the right, we're showing a panel that would be installed at a base station that has multiple transmit-receive elements built into it. These would be operating at the very high frequency range. These individual elements, therefore, would be very directional. So you have a lot of reuse of the channels here. So you have very, very tight sectors that are going to be transmitted here, and this is how you're going to be able to support very high data rates in very small locations. So this antenna technology is known as MIMO, multiple input, multiple output. We have some MIMO today. MIMO antenna technology was introduced with LTE. So this MIMO antenna technology is being advanced, and this is what we're going to start seeing. You're also going to see advancements in the network technology itself. Again, ultra-dense, numerous small cells to provide these high data rates. Flexible architecture. So the telecom networks are going to start looking more and more like IT networks, basically. You're going to have software-defined networking. You're going to be able to configure elements within the networks via software, so you most likely will not have very much specialized infrastructure equipment. You're going to have, like you have in the IT network today, a lot of cloud computing. You're going to have hardware that can be configured by software, and that allows network function virtualization. So the operators can configure the networks for the type of services they want to provide. The networks can also be smart enough to do some self-configuration depending on the types of devices that they detect accessing the network. So when is all this going to take place? So here's a timeline of the next 5 years. So what we're showing here is on the bottom, 3GPP, this is third generation partnership project. They are writing the specifications for 5G today. They will be introduced in 3 releases. Release 14 later this year, release 15 in 2017, and release 16 in 2018. So you can see by these releases, 3GPP has defined previous releases as well. So what we're in today is release 12 and release 13 for LTE. That's been defined by 3GPP. So 5G will be defined in these 3 releases by 3GPP. These releases then will be fed into the ITU, the International Telecommunications Union. The ITU will use that to define the performance requirements for IMT 2020. IMT 2020 will be the basis of 5G. So those will be the performance requirements for 5G. So you've got multiple industry organizations working today. Up at the top, what we're also showing here, in addition to the IMT 2020, you've got the World Radio Conference, which is also ITU. You've got WARC 15, which happened a few months ago. WARC 15 identified some spectrum for 5G, 3.4 to 3.6 gigahertz, I believe. So this is going to be used globally. So this is what's important about WARC, is it identifies frequencies that can be used throughout the world that are going to be consistent for these services. WARC 2019 is going to identify additional 5G frequencies. So these are going to be in the higher frequency bands, you know, probably around the 20 gigahertz bands and above. So in summary, 5G will be use case oriented, very flexible networks, providing end-to-end performance, whether that be high bandwidth applications or very low bandwidth applications. It's going to be real time, very low latency for these critical type applications, like your vehicles communicating with each other. It's also going to be very fast, taking advantage of these new spectrum allocations that we have and all these new usage, like video and augmented reality. And then finally, it will enable a fully connected and mobile society. That is the ultimate goal here. And create an ecosystem for technical and business innovations. This is being the mobile technology is incorporated into everything we do these days. And there will be lots of improvements in how things are done, lots of entrepreneurial applications, and lots of future innovations to come. Thank you very much.
Okay, thank you very much, Mark. So any question from the floor? Yes, Stu.
Yeah, so Mark, thank you. This is really helpful. Two questions, if I might. One of them is LTE already incorporates a broadcast video profile with interactivity. Given the incredible growth in video and short-form unicast stuff, I guess mainly today, but broadcast solves to a large extent the clogging of these pipes with video, and yet we don't see any, at least not I'm aware, maybe you could enlighten me, any LTE broadcast video on the air. The ATSC MH combined with the phone didn't seem to go anywhere. The Qualcomm initial thing is it a matter of timing? Is that not on the horizon, or what's your vision for broadcast video over LTE or broadcast video to the phone, maybe using ATSC 3.0?
Yeah, I'm not sure about ATSC, but I know that the operators are all looking at this, and I thought I'd seen some releases of applications for broadcast video. I know it's not a huge usage application today, but I know that the operators are all working on these things.
I mean, I understood the base station infrastructure as it exists wasn't really, even though it was part of the standard, it wasn't really suitable for it. It doesn't support the single frequency network. Right. Kind of overlaps and transmissions at the same time. But I had not seen any releases of it. You know.
Yeah, I thought there were some press releases recently. Like for example, I thought Verizon had done a press release about some applications like that recently. So I don't know. And I mean, again, the networks, 5G, I think that capability is just going to be part of the spec. It's going to be built right in there to support it.
Let me step away from the technology for a second, because I think broadcast video is of great interest to us, and we also have involvement in the ATSC 3.0. So forget what the technology is for a moment. From the operator's point of view, is there a business model there, is something of interest? They did not adopt any partnerships with broadcasters. They didn't adopt. Is there an advertising supported video with video commerce coming back over the? I mean, is that on anybody's radar, even though the technology might support it?
Yeah, I can't answer directly. I'm not sure personally, and it might be something that the individual network operators have to answer. I don't know. I don't know the answer to that question.
Because I'm sorry, I don't want to monopolize it, but just to finish the point, yeah. It seems like, just selling high-speed data, which is causing them to make these massive investments in infrastructure to support that, is not necessarily really in their best interest. That they make more money off of selling voice probably than data, and this is a way of unclogging the pipes. So I'm surprised I didn't see more. Okay.
So you had a comment?
Just on to that question, I kind of, for my 2 cents, I think there's a bit of a conflict of interest. Right? The reason you hear the carrier speaks a lot about. And the reason is that you have traditional ones for high-speed data being delivered to the home now, right? You have these other carrier folks, and then there's the distribution, right? So the difference between the Comcast and Time Warners versus the AT&T and Verizon. Well, 5G kind of bridges that gap in terms of data bandwidth, right? So I mean, imagine your AT&T with DirecTV, right? You see what I'm getting at? That there's a lot of graying of the lines between what was the high-speed data delivery, who's going to own that, and whether it's from 5G delivering for that, or for who has to be able to have a pipeline to deliver 4K and 8K video content. A lot of weird areas.
There has to be a business case too. Yeah, I mean, you have to look at the operators individually have to do their own business cases.
Yes, Brian? Oh, okay,
I
Brian.
have a question about it, which is, I'm sensing kind of a gap in the timeline for adoption, which is, but what you said originally, in the beginning you're saying you kind of expect the deployment around 2020, right? But also your timeline for the standard right here says that the standard, the true 5G standard really delivered about 2020. So clearly there has to be, isn't there about a 5-year gap to actually, once the standard is actually delivered for true 5G, to be able to, build, test, and deploy? I mean, so, right? Am I missing something?
Yeah.
Or doesn't it really mean deployment's actually closer to 2025 if the standard doesn't come to 2020?
Yeah, it's going to be a gradual deployment. I think you're going to see some of the first turn-ups of the service around 2020, but with the releases, the individual releases coming out of 3GPP, there'll be different functionalities in these releases. So the companies that build the network infrastructure and the companies that build the devices that access the network can start seeing what these releases are and can start preparing for this. Now these are fed into ITU to put a global stamp on it and put the performance requirements on it, but the basic specs for the service will be coming out in these three pieces. It's just like all the, if you looked at 4G and you look at how that was rolled out, you're probably going to see something similar here. You're going to see, it's not going to be instantaneous, like when a time frame hits, and each network operator has their own deployment schedules for this, but we're expecting to start seeing some of these be deployed for the first time around 2020.
But it's kind of fake. I mean, for instance, today, I would go to the Ericsson booth and see a 5G demo, even though, as we see, we're not even close to fully defining what 5G really is, right? So, I mean, there's, Japan, South Korea saying they're going to have 5G balloons for the Olympics and all that, again, before the standards even out there. So people are kind of taking some poetic license with what 5G really is, right? I mean,
that's been done in the past too for 3G and 4G. So that's where it becomes difficult. There's nobody that says, here's what 5G means. You can only use the term 5G for the following. So there's some marketing that goes along with this too. So yeah, I mean, some of these are marketing campaigns.
The technology always seems to precede the standards anyhow.
Oh, of course. Yeah. Thank you.
Simon have a comment or a question?
I think I had one comment, which release 14 is expected to be the actual primary 5G release. But yeah, so you're still going to get 3 or 4 years to get a good handset. But my comment was for Stu really. There was some research which showed that for handsets, people didn't like broadcasting because they wanted to have full control, because they wanted to be able to actually watch that program from the start themselves. So broadcasting on handsets never really got anywhere. As I said, we saw it with ATSC mobile, we saw it with DVH as well.
Just if you look at the amount of video that's out there in people's eyeballs, even the growth rate you have over there can't accommodate the amount of long form advertising supported video. Now, maybe that never goes to the phone. Maybe the phone always remains a short form, interactive thing, but I don't know. There are a lot of people watching video.
There sure is.
You draw a line between long form, short form, interactive broadcasts.
Yeah. I look at my own teenagers, that's what they do.
Any more comment or question from the floor? Okay. If not, we will close the session at this stage. Okay, thank you very much, Mark.
All right, thank you, Nicholas. Thank you.